This lesson describes a program that calls the methods of the session bean that was deployed in the previous lesson. The methods are called from a standalone Java program. The program is called CCountClient, and you'll be glad to know that all the hard work has already been done. That was done in writing and deploying the bean. Actually using the bean is simple. Well, it's relatively simple. The imports include the two interfaces. Notice that they are declared as being members of the package that was defined earlier. The classes are actually in the jar file that was constructed during deployment. I'll show you where that file is and how it works here in just a minute. This is the string that's going to be sent to the bean for the counts to be made. This whole thing is done inside a try-catch block because the method calls in here throw exceptions. There are different kinds of exceptions that are thrown, so the catch statement here just catches the general exception object, which will catch any kind of exception thrown. A more robust application would check for each type and do something with it, but this program is being kept as simple as possible. The very first thing that needs to be done is to get an initial context object. This object is used to locate the bean by its JNDI name. It's called what it is because it provides access to the first context in which you will start searching for the name. The JNDI name tree is sort of like a directory on disk, and the name you're looking for is somewhere in a subdirectory of that initial context. The first step to finding the bean is to use its JNDI name by calling the lookup method. The return value is the object that's in the table that's associated with the specified name. The string you pass to this method must be the JNDI name that you assigned to the bean, not the name of the bean itself. If you know the full context of the name, you could provide a path name in the JNDI table. Next, there is a call to a static method named narrow that's in the portable remote object class. The argument passed to it are the objects returned from the JNDI lookup and the class that you want to cast it into. You possibly could use a regular cast here and just cast the object to what you want, but it could be that you actually have a special remote object and some sort of conversion may or may not be needed to convert it. At any rate, the object returned from this method call can be cast into something that implements the CCount home interface. You can think of narrowing as sort of super casting. It may return the same object or it may return a completely different object of a local type. This is the last step into getting the method calls that you want to use. The create method returns a reference to the CCount object, and that object has the methods in it that can be called directly from this program. From this point on, the bean can be treated just as if it were a local object. All the accessible methods in it can be accessed. Here are the calls to the bean's methods. In each case, the string is passed to a method and the returned integer value is then printed. Now, if you have a program with a number of beans, you'll need to do the same thing for each one. You call lookup to find it, narrow to cast it, and create to get your local reference to it. Once you have it, you can keep it and call its methods as often as you like. I have a script that compiles the client program. The class path is set to dot, the current directory, and two jar files. The first one is the standard J2EE jar file. The second jar file is the one in the current directory that was constructed by the deploy tool. This jar file contains all the objects needed to compile and run a client program. Now, this compiles the client program into its class file. Now it's ready to run. The class path must be set, so I have a simple script for that, too. The class path is set exactly the same way it was in the previous script, and the program is run by executing the Java program. There. The output from the program is a copy of the string and the results of calling the 4 methods that return count values for the string. If you've followed me all the way through to here, you may be thinking that this is one heck of a lot of work to be able to call a couple of methods, and you're right. But if you keep the whole thing in context of its purpose, you can see some advantages of doing things this way. If you have dozens or hundreds of beans being used by multiple clients, you can be assured that the transactions and security and accessibility will remain intact. And once you have a bean deployed, it's there for everyone to use. Now, I'm not going to get on a soapbox for or against beans, but I do want to say that what I just showed you is only an example. It's nowhere near being a useful application.